Good morning. In the first part, we discussed the tools that are useful during installation assembly. In this part of the course, however, we'll talk about making holes. Making holes in the form of drillings for air diffusers, or making openings for grills for air intake or exhaust, as well as making holes in walls to run ventilation ducts between the distribution box and the plenum box. Welcome to the next stage, or actually one of the very first stages after the design phase, when it comes to construction work related to heat recovery ventilation. This involves preparing openings for plenum boxes, extensions, adapters to install the anemostat frame and the anemostat on the other side, or preparing holes for pipes connecting to the plenum boxes to the manifolds, or for connecting the heat recovery unit itself. So, we have two options. The first option is to leave the appropriate openings right away at the stage of pouring the ceiling, or the second solution is to drill into the concrete. I'll point out drilling in concrete, because in my opinion, chiseling or cutting through reinforcement is not in line with proper construction practices, so the only correct way to make openings in concrete or any passages through concrete is to drill into it or to cut the concrete. So, going back to this stage, when it comes to connections to the plenum boxes, the diameter of the plenum box is 125 millimeters plus the wall thickness of the material used, whether that's a plastic extension or, for example, a Spiro steel pipe. It's best to leave a hole in the concrete with a diameter of at least 132 millimeters. As for the main connections, the connections of the main thick shaft cables, starting with the cable from a pipe with a diameter of 160 millimeters, we're talking about the internal diameter, it's best to leave at least 200 or 210 millimeters, depending on the thickness of the insulation you want to use for the material. Next, when it comes to a 200 millimeter opening, again, referring to the internal diameter, it's best to leave 240 millimeters, or in the case of a pipe made from EPS material, at least 250 or 260 millimeters. However, there is one more diameter, actually two diameters, that we use when connecting the intake and exhaust grills. That's at least 250 millimeters, or it's also best to leave an extra 20 or 30 millimeters on each side. So here, you should make holes of 310 or 320 millimeters, or if you're leaving space for a grill that's two sizes bigger, 315, then again, to 315, add at least 50 or 60 millimeters. So we're talking about 350, 360, or 370 millimeter holes in the concrete wall to properly make the passage through the wall. So, to sum up, if you have a ventilation or heat recovery system design, right? You can already leave openings at the stage of pouring the ceilings, or later, there's the extra work, the extra task you have to do, which is drilling into the concrete to prepare for the passages for plenum boxes or for the manifolds. When installing a heat recovery system in a house, it's best to consult with the installation designer as early as the architectural design stage of the building, so that you can properly plan certain solutions, like the thickness of insulation, whether it's thermal or acoustic insulation on the floor, or, for example, the location of passages or openings needed to connect the components of the heat recovery system, such as extensions for the plenum box or connections for the manifold and the heat recovery unit itself. So it's best to plan all of this right away at the design stage, both the architectural and installation design. So I invite you to visit cnic24.pl in the projects section to streamline, improve, and speed up the work later on during the installation of the heat recovery system. When it comes to matters related to the location of supply or exhaust points, it's best to determine this at the design stage, ask the investor or check if there is any planned interior arrangement or lighting design, so that our supply or exhaust point can fit into this arrangement project in an aesthetically pleasing way. Right? Because we have certain guidelines regarding the location of supply points, for example, like we are here in this room. This is a bedroom, where on the ceiling we have a point marked about 60 to 120 centimeters away from the partition, so we can mark such a point from the center, right? So, from the room side, drill a pilot hole to the other side, and then from that side, use a hole saw to make the opening for the air diffuser, meaning the size of the grill, so that it fits properly with the passage from the plenum box above. If we're talking about a 125 mm connection, the hole should be at least 132 mm. If the outlet from the plenum box for the air diffuser is 160 mm, it's best to make an opening with a diameter of at least 170 or 180 mm. That's how it is for the supply air point location. However, a very important issue when it comes to drilling is to keep in mind that we're drilling into concrete, which has its own thickness as well as weight. A piece that might fall from above to below could damage certain elements, so you need to properly protect the floor or whatever is underneath, so that you don't damage it with the falling piece. An important issue also concerns the windows. Because if we don't have windows, like in this case here, then we don't need to protect the windows, but we also have to keep in mind that when we're drilling, we're doing it wet, so water mixed with debris and concrete can splash onto them, so it's important to properly protect the window to avoid damaging or dirtying it. Let's move on. We would like to present the procedure for making an opening in a concrete partition, whether it's a ceiling or a wall, using a hole saw with a diamond core bit. Before starting the work, that is, before drilling, you need to take care of your own safety, meaning you need to follow health and safety regulations. Wear work clothing and footwear, and make sure to protect your hearing and eyes by using earmuffs or safety glasses. Secure the work area, because the water used to cool the core bit can dirty or splash the walls or windows in the room below. Or the falling core during drilling could, for example, damage the floor. We can divide the process of making the hole into several stages. First, we mark the center of the hole where we will be drilling. Next, we can do this by making a pilot hole from below, from the room underneath. The hole should be sealed to ensure proper cooling of the core drill bit. Once we have marked the center of the circle, we draw the correct dimension of the hole that we need to make with the diamond core bit. To properly and effectively make a precise hole with a hole saw, the very first crucial step involves securely anchoring the drill stand. This ensures stability and accuracy throughout the drilling process. Following this, it is essential to meticulously level and thoroughly stabilize the stand, guaranteeing a perfectly perpendicular and clean cut. These foundational steps are vital for achieving optimal results and preventing any potential mishaps during the operation. We connect the water source, whether it's mains water through a hose, like a garden hose, or we use a water sprayer. Next, we drill the hole, making sure to provide proper cooling for the core drill bit to avoid damaging it. If the core from the hole falls down, we need to remove it. If it remains inside the core drill bit, you also need to properly remove the core from the diamond core bit so you can proceed with the next drilling, the next hole. That's a brief overview of the procedure for making holes in a concrete partition. Remember to drill holes or make cuts in the concrete partition using a diamond saw. On the other hand, try to avoid chiseling the concrete, as this can compromise the entire structure of the partition. We have also prepared a table, and in this table we provide the recommended hole diameters depending on the internal diameter of the duct pipe you want to use and the location of the hole. Whether it's a ceiling type partition or a wall type partition where we will be making holes for the intake or exhaust grill. Right now, I have a piece here that fell out of the ceiling while drilling, so if you don't maintain proper safety and the right conditions, you need to be careful, right? Because something like this can fall on us. I'm not even talking about it falling on someone's head or foot, but also on some element that might be underneath. So let's be careful in such situations when making holes or drilling. Ideally, it's best to hire a company that specializes in this kind of work, like drilling or cutting in concrete. For the ventilation system to fulfill one of its basic tasks, which is to remove contaminants from inside the building and bring in fresh air in their place, we need to make 2 openings in the external barrier, for example in the wall, one for the exhaust grill and one for the intake grill. If, for example, we have a wall built using a soft technology, like hollow blocks, and we don't have the right drill with a sufficiently large core bit, we can make such an opening by chiseling it out. We mark out the appropriate shape and size of the opening, making sure to allow enough extra space for thermal insulation. Next, around the perimeter of this opening, we drill holes using a drill bit, and then the material inside can be chiseled out, for example with a rotary hammer or another type of hammer. If at this stage of the work there is already a layer of insulation on the external wall, for example polystyrene, then we also need to make an opening in this polystyrene. Next, we install a pipe into this opening. This could be, for example, a system pipe from the Peflex EPS system. We need to select the appropriate length of this pipe, adjusting it so that the outer part of the pipe does not stick out beyond the facade. So, we have to choose the length in such a way that the external element is flush with the wall, or the pipe can be slightly recessed, about 1 centimeter into the wall. Next, we need to stabilize this pipe, making sure above all to provide the proper slope, towards the outside. For example, if water were to condense, we want the water to flow outside along the facade, not inside, into the recuperator. After stabilizing and setting the slope, we need to thermally insulate the pipes so that a thermal bridge does not form at this spot. For this purpose, we can use, for example, mounting foam or insulation foam. If at this stage of the work we can't yet install the intake or exhaust grill, to properly protect the pipe from dirt or precipitation, we install caps here on both sides, for example, caps made of plastic. Then, when it's possible to install the intake or exhaust grill, or to continue the installation from the wall, from this opening to the heat recovery unit, we remove such a cap and install the remaining elements, such as the intake or exhaust grill, or the pipes leading to the heat recovery unit. One of the tasks we need to perform during the preparatory work before installing the system of ducts and pipes for the ventilation system is to make openings, for example in partition walls, that are in the way between the distribution box and the plenum box. Depending on what the partition wall or interior wall is made of, we need to use the appropriate technology or technique to make the opening. When making an opening in walls made, for example, of hollow blocks or bricks, we can simply create such an opening by chiseling it out. So again, we first drill out the desired shape, and then chisel out what's inside. However, in the case of walls made of hollow blocks or bricks, we have to remember that the opening shouldn't be too wide, so that the wall doesn't get damaged or crack. Next, through this opening, we run a ventilation duct of the appropriate diameter, which will connect the distribution box with the plenum box. In the next part of the course, we'll discuss the placement of the heat recovery unit as well as the air intake and exhaust in the building.